Hey everyone, and welcome to IoTeaLive. In fact, I noticed that I can't at this moment in time can't even see Benjamin's feed. So you are there, interestingly. Look, we've full screened Benjamin. That's what we've done there. So I'll fix that while we're talking. It's very good. Thank you very much for tuning in. This is the second in a series of LoRaWAN based IoT lives. And today we're going to carry on from where we left off in last week's episode, trying to get a sensor connected to our already deployed LoRaWAN solution. Last week we struggled at the end because we didn't have the app key you see there, Benjamin, for the LoRaWAN devices that we've got. So we ended up sort of having to contact the supplier that I bought them from, and they very kindly sent me a CSV with the app keys that we needed. So we're offline. We managed to get a bunch of stuff connected and. Just one, in fact, thing connected at the end of last week. So we were happy. So we thought at the start of this episode, we'll connect this particular device up, the temperature and humidity one, and show you what it was that we got wrong while we were doing that, and go from there. So that is the plan. Before we do that, I'm Pete Gallagher, or Pete Codes on Twitter. Beside me, we've got Cliff Agius. And then beside Cliff, we've got the fabulous Benjamin Cabe from the IoT team.
Hello.
Just in case you haven't been to this particular live stream before, Cliff, did you want to briefly just tell people who you are? Very good. And you, Benjamin?
Someone in the chat said they couldn't hear Cliff. So I'll go ahead with my intro. Hopefully I sound okay, and then Cliff hopefully will fix your audio. So I'm Benjamin Cabe. I'm based out of France, and I work at Microsoft on all things Azure IoT. And I spend most of my days putting together some great content for developers for showcasing what IoT is all about, and how to use the Azure IoT platform, which I guess brought me to spend quite a lot of time on LoRaWAN these days.
There we go. I think I figured out what happened with you, Benjamin. I think you managed to dial in on Cliff's screen share. I don't know how that's happened. So that's why you were appearing big on one of those screens there. But I think I've fixed it for now, and then we can fix that offline. We don't need to worry people with that. So I think Cliff, as well, as a result of that, you were also muted. So do you want to quickly say what you said again, but not off mute this time?
Okay, hopefully you can hear me this time. My name's Cliff Agius. I'm a .NET developer, mainly working in IoT and Xamarin Spaces. When I'm not doing that, I get to fly 787s around the world for major UK airlines. And I'm here to learn a bit more about this LoRaWAN and carry on from the fun we had last week.
Awesome.
Hopefully you heard that.
Yeah, I think they did.
I saw your...
Yeah, Johnny's good to have, so that's good.
I know what happened with that one as well. At the very end of the IoT Live we did on Tuesday night, I flicked over to the end credits and your mic was still active, so I muted it, and then obviously I've forgotten to unmute it. Amateurs, that's or at least me.
We're learning. This is only our third show, I think, isn't it?
Exactly that. Benjamin, I don't know if you wanted to come in on your stream, if you wanted to just disconnect and then click on your stream instead, and me and Cliff will quickly chat while you're doing that. It saved me having to realign all of the different scenes live while we're trying to talk. Is that okay?
Sure, except that I'm not sure which link I should use, because I really didn't realize it was the wrong link.
It's in the invite that I sent on your calendar invite. There should be a list there.
Just the one in our Twitter DMs.
I think that was my fault. That was an old link. If you missed it on Tuesday night, we had our second sort of IoT recap with myself and Cliff, but we also had Liam Gulliver along because Liam and I ran a talk together for the first time for the British Computing Society, and we demonstrated the IoT robot arm that I'd built in .NET. But we'd hooked it up, very similar to the one that Cliff's got there. In fact, Cliff's is better than the one that I've got in many regards. So I had all the code and everything in the workshop already prepared for that. But what we didn't have was the cool bits. So what Liam and I worked on was deploying the Blazor and SignalR stuff up into Azure, and we were able to then allow people remotely to control the robot arm. It was really cool. And then we demonstrated that again on Tuesday night, and it was cool. Shahid has moved over all the way to New Zealand, and he was able to move the robot arm remotely from New Zealand, that was pretty cool. So first transcontinental robot arm movement for the robot arm. So that worked out quite well. Are you back in the right place now, are you, Benjamin?
I would hope so.
Yeah, that looks like it to me. That's good. So that's loads of different screen sharing options, but happy with that. So at this point, I guess if we switch to your screen share, Benjamin. So I've got your screen share up on the screen now. We can carry on from where we left off before. So I need to also dial in, don't I, on my machine to that same Azure resource, which I'm not quite sure what the address was. I forget now. Let me have a look.
And I'm realizing I don't have it handy either, so I'm going to need a few seconds.
Do you want me to take you off screen share while you figure that out, Benjamin? Or
maybe.
We'll do that. So I've got the Pico producer. That seems to be working all right at the minute, actually. Thank goodness. So I'm able to switch between scenes with the Raspberry Pi Pico controlled macro keyboard that you might have seen quite a few people using. So I don't know about the link thing. The link thing's even working. Ignore the link. That's from Tuesday night. But quite happy with that. It's something.azure websites, isn't it? Let me have a look. See if I can beat you to it. I thought I had it in I've got a little details thing here that I've kept, but it seems as though I've not kept that. So, what was it called?
Yeah, it's I can put it in chat.
Oh, that's it. Things network. Things something or other.
You found it quicker than I did.
Ah, here we go. There we are. Yeah, I think Benjamin's found it now. Oh, in fact, it says it's refused to connect. But I don't know if that's mine or not.
Yeah, it should be fine.
Oh, there we go. Yep. Oh, did you have to start it up?
Yeah, I don't know. My internet is really slow for some reason. For a few months ago, I moved in the countryside, and today, part of France I live in is super windy, and today is one of those days. And all things power and ADSL are just really not great today due to the wind. And I think we're back in business now.
Yeah, I reckon we are. So if I just switch across to that screen there. So this is the Things server that Benjamin has spun up in his Azure account. And I've spun up one last week as well. But we're going to carry on with Benjamin's because it's all provisioned. We know it all works. It has already got some devices. And we're going to build some stuff on top of that then. So the first thing we're going to do is connect my second device. So I have got over on, if I share my screen, there's a bunch of devices there, of course, but I've got these devices sat on my desk here, and I've not even pulled the tab out of this one. So I'm not going to do that right this very second. I'm going to wait until you what?
New.
It is exactly that. It's not even had the seal pot. So we need to provision that into Benjamin's infrastructure first. So actually, should I be sharing my screen and logged in and do it that way like we did last time? Is that a good idea?
Yep, I think that would be fine.
Yep, so let's get that on the screen. So this is the end devices. Now, let's see, I need to get Zoom it open. One of these days, I'll be like prepared for the start of one of these streams. I went out for a quick walk with the kids beforehand thinking, and I got everything set up, but obviously I didn't get quite everything set up. So there's the motion sensor that we set up before. So that is the this device. I'll show you. This device here, so it's got a little motion sensor on one side of it, and that's what we've managed to get provisioned at the end of the stream. After everybody had disappeared and we figured out what was missing, we managed to get that provisioned. So we were missing this app key. I think it's an app key, isn't it, Benjamin? That's what it's called. Yeah, the app key.
Yeah, so it's essentially the yeah, it's like literally a key, a secret that maybe for good reasons actually the manufacturer is keeping a secret, and they just forgot to tell you about it, right? But we had and we still have the unique ID of the device. That's one thing. There is another identifier that's more for identifying what network the device is going to join. And then there's the unique key, right? And we were missing that part. So there really wasn't any way the device was going to successfully connect. But now with the key, the motion sensor is connected, and maybe we can go through the same process for the other sensor, right? And essentially just provision it onto our own network. Like you have the gateway. Gateway has been connected for the past week, I guess, right? And yep. It's doing its magic, and so we just like need to make sure that the device is provisioned, because right now, even if your temperature sensor is powered on, anytime it's trying to broadcast some radio LoRaWAN packets into the air, your gateway picks it up. Your gateway forwards the data to the network server, but the network server is like, I don't know about this temperature sensor. It hasn't been provisioned, right? And I don't know. I don't even know about the unique ID of the of this sensor. So let alone the key, right? We don't have the device at all in the backend. So let's fix that.
Absolutely, sounds good. And thanks to Everoth, who has subscribed using his Prime benefits to the channel. So thank you very much for that. The other good thing is that Benjamin and Cliff can now also paste links in the chat, because I've given them the power. So that was something that was missing from last week as well. And I've got that silly link thing that will work one day and not the next for me as well, that we can pop up in the middle of the screen. So it's a couple of little improvements. So back on the sensors. So I've got this this temperature and humidity sensor with, and that's kind of what it's doing on the side of that. I'm keeping the very end of it away from me, because that's got a QR code and some identifiable information on there. Although to be fair, you can't do anything without this new app key that we've got, as Benjamin has said. So you are most likely going to see the parts that we're talking about anyway. So what I'm going to do then is I've gone to Benjamin's server instance, ThingStack server instance here, and we need to add a new end device at this point. So I'm going to click that, and if you remember from last week, we used this over-the-air activation mode, OTAA mode. So we're going to leave that as it is, and I think, what did we use, 102 or 103 last time for the Mac?
Yeah, 102. This is one of those areas where I don't think the documentation of the sensor was super clear. So unfortunately, it might be trial and error for this step when it comes to provisioning LoRaWAN devices. Like LoRaWAN is a standard, but it's also a fairly new standard. So in the wild, you would find sensors from maybe 2 years ago that implement one of the first few drafts or the first few final versions of LoRaWAN, and then devices from maybe 9 months ago who implement a slightly more recent version. So the differences are pretty small, and like in most cases for the kind of communication like patterns we are looking at and the kind of info we are after, I don't think it really matters which particular flavor of the LoRaWAN spec we pick. But yeah, 1 or 2 worked last week. It should work this week.
Yeah. Well, you've just ruined it by saying that. Yeah, jinxed.
Maybe.
So we're gonna go with whatever it's given us here. What was this external join server about? I'm not quite sure what that was.
Yeah, we could look at the diagram of a typical LoRaWAN backend, but essentially the idea is that you can have different clusters or like different aspects of your actual server, like the component in charge of actually provisioning the devices the first time they ask to join the network might be sort of a different entity. You may have, and in particular, because there's some specific secrets that you may not want to have as part of the rest of your network, like the join, the provisioning workflow might go through a dedicated data center with maybe specific HSM and things like that. And so that would be the stuff that the server would be reaching at. That would be the join server, and that would be what you would be configuring. And then you have like other aspects in your cluster, like you may have a specific service in charge of just managing the application and the data related to the applications that you run on top of your LoRaWAN network. And like essentially in the things stack backend, you can have all those services or microservices potentially running on like different servers or different containers, right? Right now, everything runs on the same VM in our topology, but yeah, we could have a join server somewhere in a more secure, maybe, piece of our data center or piece of our backend infrastructure.
Interesting. Okay, so we can click the start button. Need to enter the device ID, the end device ID. So I've got that over here. In fact, let's do this. And it's this. So I'm not bothered about anybody seeing this because you can't do anything without the next bit. So the
this one you may even want to put like, I mean, it still needs to look like a unique ID, but it can be words, like it could be my temperature sensor 001. I mean, it doesn't matter. I think like I'm looking at last week we had Pete-motion-1, so maybe today it's going to be Pete-temperature-1.
Yeah, no, yeah,
it doesn't matter. It's more like for whenever you're going to use APIs or things like that to interact with the data, or actually more importantly, maybe this is the one ID that is when we will start pushing data from the things tag to Azure Digital Twins. That's the one ID that's going to be surfacing. So it might be fine to use the MAC address like stuff, but it might also be better to have the what you put is
human readable sort of a thing.
Yeah,
that makes sense. So I mean, I've got all of these. All this information actually was contained on the QR code and the bags that these devices came with, but they're also contained in the CSV that we were sent very nicely. So that makes my life a lot easier now because it was a bit of a pain. So I can't scan QR codes on my machine here. I had to scan it on my phone and then copy stuff across, and it just wasn't very nice. So I'm copying out of the CSV file and into here now, into the browser, so I can paste that one in. So that was the app EUEUI one, and then the next one is that dev EUEUI one down there. And in my CSV, that the titles of these columns match up exactly, which is really nice actually. So that's them ones. And then we've got a device name we can give this as well, which would be like Pete's temp and humidity sensor, and temp and humidity in Pete's office or something like that. And we're happy with that. So network layer settings, frequency, we need to choose the EU frequencies. Down, where have they gone?
It should be at the very top.
Oh, that's because it scrolled off the page. That's why. This one, the recommended one. That's fine. LoRaWAN is locked. Regional parameters. What did we choose? Rev A? I think we did.
I think we went for A.
Yep. Did you say something there, Cliff?
I thought we went with B last week. But...
Did we?
Let's go with B for this one then and see what it does. We'll leave those two things off because we don't know. And then join settings. So this is where we got stuck last week. And I'm going to stop screen sharing because this is the part that is identifiable. So I'm going to go across to here and I'm going to put that code in to here. And then I'm going to add my end device. There we go. And then I can flick back to here and then you can see where we're at. So I've not even unplugged I've not taken the little plastic strip out yet. So we're definitely not going to get any live data at the moment. But I'm going to go to the live data page and I am going to pull out the little plastic strip so that it should theoretically try and connect. The reason why I did it that way is because I'm hoping that will actually shortcut the length of time it takes. I'm hoping the first thing it'll try and do will be try to connect. Otherwise, there is a delay between connections. Obviously, these things are supposed to be low power. That's what the LO part of LoRaWAN's about. They connect infrequently, but we can change those parameters, and we did that offline as well. But in another show, we'll show you how we went and did that, because it's a little bit off topic for what we want to do. But you can send commands down to these devices with parameter change requests in them. And one of those parameter request changes is how often it communicates with the server. Obviously, the more often it communicates, the more power it's going to use, and the faster the battery's going to die. That's just how it's going to be. We are still waiting for events. We also get stuff in the... Where did we get stuff before as well?
Interestingly, the other sensor, the motion sensor, just sent some messages. Oh yeah, it's now coming. The other one is communicating every minute. And yeah, the temperature and humidity.
Yeah, we changed the default time on the motion sensor from 5 minutes, I think, didn't we, down to 1 minute. That was because we wanted to prove we could do it, apart from anything, but also it's better for demonstrating. But if the humidity, I think the humidity sensor already was quite a fast update.
And it just connected.
Oh, did it? Okay.
Yeah, if you want to share my screen, I was looking at the logs and I have them.
There we go. You might want to zoom in a bit.
I think we went through that last week, like the logs of the things stack, like the very nature of like a network server, I guess it's not specific to the things stack, is that usually it acts as a broker for actual consumers, right? And so the logs and all the messages, like the things stack, the network server is not like storing them. So you may be looking at the logs in your web browser at a given point in time, and the web browser can like show you everything that's going on. But if you're not there when things happen, then like you don't necessarily like it's too late. Like it's really being brokered. But yeah, I had the page open, and now it looks like the device is sending data. And if I'm looking back, actually, the first, let's see. So the motion sensor, yeah, that was the motion sensor communicating every minute or so at 3:19:20, and then at 3:20:20, and then Pete created the device. So I caught that in the logs, and then the motion sensor started to speak again, and then the humidity sensor was like, hey, the plastic thingy is gone. I have power. I need a network. And so it actually broadcasted a join request. We could actually dive into how the join requests look like, but it's essentially a datagram, a radio packet, which is like, hey, here's my device EUI. Here's my willingness to join a network. And by the way, I'm signing my request with the app key, right? And so this packet gets transmitted into the air. The gateway picks it up, forwards it to the server, and the server is like, a device is trying to join. The device is telling me that it's called this, and that it's trying to join with like this network identifier. That sounds good. Is the device, I mean, I know about this device, and I even know, like, I know about the unique key, the app key that the device is supposed to be using. So let's check, let's see whether the device is effectively, like this is a MIC, a message integrity code. And so what the network is doing, and it only takes a microsecond, right? It's like, hey, this MIC is supposed to be a hash, a signature done using the app key. Like the device, when it sends a join request, it should sign the join request with the key that only it knows, and only it and the server knows. And so that's what the packet looks like. And the actual, like the full radio datagram is this guy over here, with all, like, again, the device UI, the MIC, etc., etc. The device also says, by the way, or the gateway says that it's a join request that's been sent by the device using a particular LoRa frequency and blah, blah, blah. And then where were we? Yeah, the server received the join request, forwarded the join request to the join server, and like we just said before, the join server could be a different entity, right? And the right now it's all running on the same VM, but it could be a specific microservice in charge of checking that the join request is legit, and more importantly, turning the join request into a reply that should be sent to the device in the form of a unique app key, a session key, app session key for the device to use from that point in time. That means that essentially that super secret key that you've been using, Pete, it's hardly ever used and ever like used for the communications. It's only when the device joins the first time that it's being used to make sure that by the server to make sure that the device is authorized. But then there is a like another derived key essentially that's created, and that's sent back to the device, and that's from that point, like this derived key is what the device is going to use to communicate. And yeah, the join request, we accept the join request, we reply back with a join accept message to the device, which is where.
Did you want to zoom in just a little bit, Benjamin? I think it's a little bit small for a couple of people.
Is it?
A little bit. Okay. Yeah, it might be a bit better. Thank you.
Let's see. Yeah. We generate the join accept message, which we then send back to the device, and then the device from that point in time is like effectively joined, effectively provisioned, and so it starts sending data, and quite often apparently, right? And it's sending like application data. We don't worry about like the joining and the provisioning workflow anymore. We just have like we're in business. And if we look at let's see, well, we have tons of sensors actually. There's mine, there's your motion sensor, and yeah, your temperature. Yeah, that is an actual payload being sent by your sensor. And here we will probably need to do the sort of the math and map what we see here with what we have in the sensor's data sheet. Because if we look at, so this time it's really like an actual data packet, as opposed to earlier where it was join requests and things more like that have to do with the network itself. This time it's an actual data packet. It's an unconfirmed one, which in LoRaWAN terms is it would be almost the equivalent of a UDP transmission, right? Like it's a fire and forget a message that the sensor is sending. It's sending its temperature. If for some reason it doesn't make it to the server, it's not waiting for any form of acknowledgement whatsoever, but it could. There's also a notion of confirmed uplink messages and confirmed downlink messages. And then what do we have? Again, this MIC thingy for checking the integrity and the and for authenticating the messages. And then we should have somewhere, where is it? An actual payload. Where is it? For some reason now you had me zoom so much that I cannot see the payload. Do you guys see it? MIC payload. It looks like the device might not be sending that much data actually. What are we looking at? Yeah, we should look. Maybe I'm not looking at. Let's see. It, and I'm gonna do.
I was going to get the data sheet.
Data message.
That's what you're doing already. Look.
Or,
Yep. Oh, is it? No, that's what I'm doing. Yeah,
where is the payload?
What would you expect to see in the payload? What is it?
It should be some base 64, like short. Yeah, but the payload actually looks like it is just empty. So maybe this is where we'll look at the data sheet, right? And see what are the different frames that the device is supposed to send.
So if I switch to my screen share,
Yep.
I'll try at least. Got some bugs kinks to work out in my Pico producer. Sometimes it just works and sometimes it doesn't. I'm not quite sure why.
I think I finally found it.
So this is the data sheet for the temperature and humidity sensor, and I'm just scrolling down until I find something. So messages, there we are. Status, battery, temperature, environment, relative humidity, and then I think it's like a multiple use software for this. My one's just temperature and humidity. I don't think it's got CO2 and what's VOC? I forget what that is now, but
volatile organic compounds.
Ah, yes, like Trumps and things like that. So it should be that we get in the payload, we should just get a single byte, and everything's in that single byte.
And when for uplink messages, there's this notion of ports. So just like for TCP/IP and UDP/IP, or for IP, I guess I should say, you have the notion of ports, which can be used to differentiate for a given endpoint. Like it may be using different channels to send information. And so the table we were looking at earlier, I think it said that port 107 is used for those datagrams. But I think the device is actually also sending data. Yeah, there you go. The payload for 1.2 paragraph for 1.2 port is 107. The messages that I think your device has been sending so far, they are on a different port, aren't they? Yeah, I've seen messages on port 222. So this one is, I think this one might be more for like configuring how often the device communicates. I'm sure there is somewhere in this spec. If you search for 222, there should be another sort of category of messages.
Not so much.
Oh, really?
So no, nothing about 222. I can hear myself back somewhere as well. I'm not quite sure where that's from. But no, just that one message. There's no mention of port 222 whatsoever. Obviously, if I type for...
We're looking at the right sensor data sheet versus the right data in the Things network. We've not got the two sensors mixed up, have we?
Yeah, this should be the temperature and humidity one that I've got on my screen now, and there's only the one reference manual for this one as well. The other one had two reference manuals, and this one, this operation is... transport mode, which is with the little plastic strip in there, and then default operation. During default operation, the device will send a message to the network. In the environmental conditions, or after 60 minutes of inactivity, the precise trigger values can be found in 4.1.1, which is 4.1. So 60 minutes, or plus or minus 2 degrees of the delta, or plus or minus 5 degrees of the relative humidity. So I'm not sure it says anywhere what those deltas are, as in what the level is that it needs to go plus or minus 2 degrees from.
I think it's a delta from what it had last time.
Oh, so just a change from the last. Yeah, that makes sense.
If the change from the last update of 60 minutes ago is more than 2%, then it'll, like, based on an alert message, look, your temperature's drastically dropped or drastically risen.
Well, I am going to breathe on this thing then, and that should change it by 2 degrees.
No, you're safe to drive, Pete. You've not been to the pub.
If only. I'd kill to go to the pub right now.
Yeah.
Oh, not right now. Obviously, we're in the middle of a live stream, and no one wants to watch us go to the pub on a live stream. But
I can all join us there.
This is true. It'd be IO beer rather than IoT then.
Could be IO tonic to go with the gin.
That'll work. So, if I go to the live data, it's last seen 12 minutes ago. I would have thought that would have been enough. What I've just done there to change it by 2 degrees, which is interesting. So I'm now holding it under my armpit. Let's see. Oh, last seen 2 seconds ago. So it did something just then.
Oh, yep, I can see it. Interestingly, it looks like it used port 103. That's not what we had in the dock, is it?
No, it was port something else. 107. Yeah. So.
Well, there's not sure what you think or say publicly about those, user manual and reference manual. There's some mismatch there.
I see where you're looking.
We'll figure it out. Do you have it in your logs? Yeah, you have the payload, right? The one. Look at the one with the payload. There you go. The 08FB3961FFF. This is.
What are you looking at? Sorry, where did you see that information?
You can share my screen if you.
Oh, sorry. Yep. For pity's sake. Hold on.
Now it seems to be sending data every minute. The payload. So this time around, we do see a proper payload for the uplink. Uplink is being sent on port 103, so we will need to figure out. We might not be looking at the right data sheet, maybe, but the payload looks like this. It's what it is, 8 bytes, and it looks like we said earlier, and like we saw in the docs. At least it seems to be consistent with what we saw, that since your sensor doesn't have VOC or CO sensing capabilities, it probably would make sense that those show up as FF, and then this is probably where the temperature is. So let me try and look at the data sheet. CO2 we don't have it. So see that's the 8 bytes that we were seeing. So that. At least that seems consistent. And then what else? The first byte is the status. The second byte is the battery. And then there is the temperature. And then there's the humidity. So let's see. The battery level. Decoding the battery level would be as such. Decoding, which one are we going to try to decode? I think we're going to try to decode the humidity. So the humidity is the 4th byte. And then we will look at how to do the decoding, not by hand, right? Because at some point we want to do we do that automatically. But the whole idea there is that LoRaWAN, there is just so much data that you can put in the radio packets. It can be as small, oftentimes as 52 bytes of actual payload. So you're not going to send JSON. You're not going to send XML, right? You're going to send packed binary data. So the humidity, in like in an ideal world, you would send like a JSON document, your curly braces, and you would have humidity, HUMIDI, blah, 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 0, 0, and your double quotes and whatnot. Here, humidity is just literally 1 byte. It's an unsigned integer, which is on the like encoded in the byte RFU. I'm not sure what that is, but yeah, the first 7 actually bits for the of the 4th byte are encoding the humidity. So let's see, looking back at the console, the payload. So it's effectively this byte like 31 in X. What's that? If I decode 31X in, I should do it by heart, right? It's 49% decimal.
Okay. That
right.
sounds about right.
That sounds about right. Maybe we do the same exercise with the temperature, and temperature is encoded as a yeah, that's interesting. It looks like it's using 32 as sort of like its 0 point. And so whatever value we will see in this time in the 3rd byte is going to be a temperature encoded again as an unsigned short integer and offset by 32, so that I guess it gives slightly more latitude in terms of what effectively it will allow to go all the way to -32 as explained here. So let's see.
Yeah, I think it was like 3C or something, wasn't it?
Yeah, 3C.
Yep.
3CX. Oops. 3CX is 60 decimal. And if I think we're looking at, so the port definitely is not the one we see in the data sheet, but in terms of encoding, that sounds about right. We could do the same exercise with the battery. Again, it's an unsigned value. It's between 1 and 14. So this time it's only encoded on the 4 first bits of the 2nd field. And then again, there's like a magic formula. Let's see, the battery, FB would be the, FB, it's 251 decimal, but then the magic formula tells us that we should be adding 25 to that and then divide by 10. Let's see.
I've just put a link to the to that particular data sheet in the chat if anybody's interested there. It's actually quite a straightforward data sheet. It seems more straightforward than the motion sensor one anyway.
Well, interestingly, I think I screwed up the decoding. It should be the, again, that's the payload. The FB is the one bit that encodes the battery level, but the F is actually, like, we should discard the F, right? It's, see what I mean?
Yeah, that's to do with RFU, whatever that is. What's RFU?
Yeah.
What was that? Whatever that is.
Like in binary, that's what we're looking at, but that's only those, right? That are encoding the voltage. So
RFU is reserved for future use. That's what RFU is, isn't it?
Yes. So yeah, we're looking at B, which is 11 in decimal, and then we add 25 to that, and then what was it? We divide by 10.
Divide by 10. Yeah, 3.6 volts. Oh yeah, you won't be able to divide in programmer mode.
Well, 3 volts might be available. Oh wait, what did I do? I was not in decimal, was I?
Yeah, it won't let you do a divide in there, will it?
Anyhow, so that's where and when we should switch to doing this automatically, right? And I think the data sheet actually has or does it? The decoding.
We found something somewhere,
it
didn't
wasn't.
we?
I think it was on the website. Was it not?
Let's have a look.
Here. All right. So I'm looking at the web store where Pete actually sourced from which Pete sourced the sensors, and one thing they mention in the description is that there is an existing JavaScript snippet that can be used to do what I just did by like mostly manually, right? And if we look at this guy, so we need to look at the one for, I think it's the combined, I'm guessing. Yes. Interestingly, it's mentioning port 103. So this is the JavaScript function that's going to take the binary payload and that's going to decode it, right? And so this is something that we can essentially instruct the network server about and tell the thing stack, hey, you know what? Whenever you see this sensor sending data, try and route the binary payload through this decoder, because that will make things much, much easier to like visualize the data. And that will also make things much easier for downstream consumers, because like we will start looking at battery and things like that, as opposed to just 8 super opaque bytes, right? So I don't know, Pete, you might want to take it from there and sort of like make your way to the section of the UI in the thing stack where we're going to put this. But essentially, this is going to be like there is this notion of payload formatters in the thing stack. And this is where essentially we can have like, yeah, a decoder associated to a particular. Well, you know what? I think I'm going to do that one because there is a small trick, which is this JavaScript function is something that's meant to work out of the box with the V2, the version 2 of the Things stack and the Things network. The one version of the Things stack we're using since last week for the stream is V3. And so they changed very slightly the API for the decoders. So we're going to need to adapt this just slightly. But let me still take this somewhere with me in my clipboard. And then looking at the Things stack backend, this is the application where we've now connected like several sensors. Some of them are actually not the same kind and not the same type as the one that Pete are using, but nevertheless, there is this sort of umbrella, or I should say sort of blanket generic formatter that's going to be applied for all devices, no matter whether they are of the very same kind as the one that we just went through, or there is one generic decoder. So we could start extending this guy to be like, hey, if it looks like the payload is coming in on port 103 as opposed to port 2, well, it's likely that it's a device from this particular manufacturer, and here's how we're going to decode it. So I could probably extend and tweak this existing decoder that I have for another kind of sensor that I've been using until now in this particular application. Or what we can do and what we will do is override the decoder for this particular sensor. There's going to be a custom payload formatter, which is going to be, so that's how it's supposed to look like. Like that's the scaffolding and the default. Like that would be typically a sort of an identity decoding. Like it doesn't do anything. They did this one JavaScript snippet, but at least it gives us a framework to indicate how we should typically approach the decoding. And if you remember, like the V2 sort of version of the decoder, it's just slightly different. Like the signature is slightly different. So it should be pretty straightforward to just like align everything. Let's see. So V2, it would expect the bytes and the port to be given as a parameter, as opposed to this, where there's only an input object, and then the bytes are then like part of the input. So we should actually be able to do something like, let's see, how did I do for the other one? Yeah, the port is going to be as part of the input. The bytes are going to be as part of the input as well. And then, yeah, we want to return something that looks like, yeah, it should be okay. Let's see. We should actually be able to do something. Just making sure. Yeah, we should be able to do return a decoder inputs and input. Does that make sense?
I think so.
Let's see. Yeah, input wise. I think that should work. Yep. And now we need to have you. Did we figure how often this guy is sending data?
The humidity thing, I mean, unless it gets that change, it's going to be every...
There we go. We just had one, didn't we?
That's probably
just right now.
It's probably cooling down, I think, isn't it?
That's the motion sensor, isn't it? Sending.
I know, we've got a temp
we just had
humidity
one, but it didn't go through the decoding, did it? I don't think it did.
How do you know if it's gone through the decoding?
Because the payload, it should actually show us like an easy to read payload. So I think it didn't get decoded.
How does it know which one of those? I can hear myself again for some reason. How do we know which one of those two? Let me just have a look actually at what you've written in there. So I'm just trying to find the code that you've just written, Benjamin. Where do I find that in my?
There you. Yeah, that's the one.
Go down a bit, Pete, and it's the next window down. Your window's not the same as Benjamin's.
No.
He's on payload formatters at the top. Go to the top of the page, Pete.
Do you have to go to the end device and then go into the end device?
Yeah, because I essentially I overrid the
got you.
The decoder for this.
That makes sense. Okay, cool. So I don't know how blurry that's coming out on the stream.
It still looks pretty blurry my end.
Yeah,
your screen seems to be clearer, so I'm not sure if it's an issue with Benjamin's upload.
Yeah, your internet might be a little bit slow. But I don't know. I don't think it's that much different. That's my version of it. So
your version's a bit clearer.
Yeah, marginally. I don't think there's much in it, to be fair. We'll stick with Benjamin's for now, though. But so yeah, we've got that decoder. That so it knows to do that decode uplink function, does it? We don't need an anonymous function somewhere that gets called. It knows to call into that decode uplink function, does it?
Yep. But let's see if it finally ended up being decoded. Yeah, still not. So I'm gonna try something different, making sure that we just get it off.
While Benjamin's doing that, Cliff, for your solution, which was like self-rolled, how did you encode your data and what did you use to decode it?
We just had we just bit banged it. We just stuck it in a byte and sent those bytes across. We rolled our own. So where you've got a data sheet there saying that bit this and bit that is there. We just sent our own small data packet that we designed ourselves, and that's how we did it.
Mm-hmm.
But we was effectively making our own sensor, so we could do that quite happily.
Yeah, but similar idea though, isn't it? It's just that.
Yeah, I mean, all you're doing is just turning a bit on or a bit off in a byte and just sending those couple of bytes. It's not yeah, it wasn't particularly difficult, but we weren't using the things network. We were just using the LoRa bit of the that bit of it. We weren't using the whole gateway because we built our own system. So yeah.
So as soon as that device sent a message, then it should have called into that payload formatter. These payload formatters are executed on uplink messages. That's exactly what it says at the top in that blue box that Benjamin just had on the screen there a second ago. And take precedence over application level payload formatters, which is where we were. So it should call into that decode uplink and then return an instance of the decoder. And it's going to pass in input.bytes and the input.port into that decoder function, which makes sense. And then if port is 103, then it'll actually do it. So when we were looking at the telemetry, it was definitely port 103, was it? I can't remember.
Yep.
Yes, it is. Yeah, I can see that in the telemetry there, actually. So definitely that should be okay. And then, so it's just got some params, which is putting into the bytes. And this is copy and pasted code out of their example code, isn't it?
Yes.
What's it? There's some complaints partway down. Read only. Status equals. And there's this complaining part down. I'm wondering if it's actually calling into it. Well, to be fair, you'd get zeros back or nothing or a null back for the payload if it was failing, surely. Because this should be just overriding it rather than the original payload being returned.
Mm-hmm.
So it just returns params. And params is temperature, battery, and then the stuff cap, whatever that is. Battery measurement.
So do you want to try and force the device to send data?
I'll try that. We should both be blowing on it slowly. And holding it. It's definitely cooler than I am. I'm assuming there's no... Oh, sorry, go on.
Yeah, no, I'm not sure we figured the pattern yet of like how often it... Oh, there we go. We just had data. Because we created the device 37 minutes ago and it only sent 8 uplink messages. So it's definitely not super chatty. And it seems to be more than just having a 2 degrees Celsius variation for it to communicate. But let's see. It just sent data and it didn't go through the decoder.
Sorry, what was that, Cliff?
It wasn't degrees, wasn't it? Percentage change.
Yeah, I think it might have been, actually. Yeah, I think you were right, actually. Let me have a look. Well remembered.
Yeah, it says network one says sufficient delta in environmental conditions or after 60 minutes. Every hour, every 60 minutes, it sends an update. And then if there's a change of plus or minus 2 degrees or plus or minus 5% relative humidity, then it sends an update.
And it has sent something, and it has got a payload, but it's the same payload.
Yeah, when you breathed on it before, obviously you made a big change, and then as it's cooled down over time and the humidity's settled back to the room humidity, it's been sending back updates, and then it's got back to room humidity and room temperature. It stopped updating for an hour, and then you breathed on it again, and it will do the same thing again.
Yeah, exactly.
So we should get a fair few updates, and then it will slowly go back to where it was.
Yep, that makes sense.
I'm on a call, dude. But yeah, thank you.
My daughter came in a minute ago. She was very angry that I was on a call.
Yeah, picture up. Yeah, okay, yeah, we can do
that. So, Cliff, your mic is a little bit echoey. I don't know, just because of what you're using or whatever, but
I think it's this newly decorated room. There's no soft furnishings.
Should have let him put the picture up.
Sorry?
You should have let him put the picture up then.
Yeah, I think all the things that were hanging on the wall and all the benches, no one else had gone, so it's become an echoey room.
Oh, nice.
I think he's just making excuses to come in now.
Oh, good on him.
No more, dude.
You'll be in trouble now.
It's Mr. 11 that built the robot.
Oh yeah, that's true.
So super excited for tonight to watch the Perseverance land on Mars.
Yeah, about 9
That
p.m.
is proper IoT. That is.
Yeah.
That is IoT. Yeah.
So I can hear myself through your. I think it's must be your PC that I can hear myself through there, Cliff. Don't know. Have you got a pair of headphones you can put on with a mic in it or something? Or
Yeah, 1 second.
So I see Benjamin scrolling through code.
I think I figured what was going on. Let me just quickly check. And for a quick check, I should have figured that earlier and remembered. We can actually simulate uplinks.
Oh, look at that. Oh, decode.
Now that's better. At least it's failing. Params is not defined. That equal blah, blah, blah. Yes.
Have a look at what
where
that is.
was I?
Well, it is. Okay, right at the very top.
Wait, where am I? Yes. Yeah, we need to read. I wonder if, since we're both looking at the same pages on both sides, like it looked like whatever I did just before, it disappeared.
Really?
It would seem so.
I was on the live data page the whole time you were editing. I've only just gone back to that.
So that was me trying to find an excuse then. Let's see.
Tut.
Yeah, as part of the V3 differences, I think the whatever we return in the decoder should look, it should be an object with a data field, and then whatever we decode it should be there. I think that should be better. So we're gonna again simulate a payload.
Yeah. I'm also gonna hold on to this.
Oh, that's better.
Yeah, look at that.
Way good.
That's cool. I like that.
So that was me. So simulating an uplink. So it's not like actual data. Well, it kind of is though, because I just copy pasted a payload from just a few minutes ago. But that's interesting to look at it now, because it's much clearer what's going on. Like, so one, we can see the 8 bytes we were looking at earlier.
Mm-hmm.
We have them in decimal form actually, so that's easier. So what was it? The first one is the status. I don't think we've looked exactly in the spec how the status is, what it is encoding, but it's telling us essentially whether we're looking at a VOC sensor or a temperature and humidity sensor. So 0, 8. We are actually looking at a temperature sensor. Then this one was, I think, the battery level, and then the temperature, the humidity, and I don't remember now, but there was this offset thingy, etc., etc. But those are like the raw fields, and then when they get decoded, the humidity is literally the same. It's the fourth byte, but then the temperature itself is it's this guy that needs to be offset by 32 and blah blah blah, and which means that it's 25 Celsius. And VOC, we don't have VOC, and CO2, we don't have CO2. Like those values, this is telling us that, hey, you know what, they're irrelevant, because as per the type of your sensor, it's not a CO2 and a VOC sensor. So those two are irrelevant. But long story short, it means that now whenever we get data from this particular sensor, and whenever we want to route this data to another system, or if we want to subscribe to the ThinkStack backend using MQTT, which is definitely an option, the data, we will still be able to get the raw payload if we're interested in the raw payload, but we will also get the decoded payload. So that's better, I guess. And that's a one step further towards being like soon being able to effectively send the data to Azure digital twins. Like the way I would describe this is when you build an IoT solution, there's many ways your devices are going to talk to the internet. Like you can have devices that are maybe Wi-Fi capable, and you have full control over the devices because you're actually like building some form of connected device. So you may end up like leveraging the fact that you have Wi-Fi and good old IP to like directly bake support for Azure IoT in the device. And so you will be using MQTT to connect to Azure IoT Hub or something like that. Or you may have other more like legacy brownfield devices that are already hooked to some kind of like backend network. You have LoRaWAN devices, you have some Zigbee devices that talk to some random platform from 10 years ago that allows to do Zigbee over IP kind of stuff. Like, and you have tons of devices potentially in your solution, and they not all of them talk using the same protocols, etc. So in order to federate the data, one way to approach things is to leverage this notion of digital twins. And so I don't like, actually, Pete, what would be your definition of digital twins?
Well, I mean, you could go all the way through to Industry 4.0, can't you? Then that's sort of what's driving this, is that big industry wants to be able to map and simulate everything from sort of the overall factory structure all the way down to individual components. And by doing that, then obviously you can simulate when devices are likely to fail, so predictive analytics and stuff like that. Obviously, you could go to IoT Hub's digital twin variety there, where we keep a twin, so a set of readings in the cloud that map directly to a set of readings on the device, and we can use those readings to keep the device and the cloud up to date with settings and readings that way. But certainly digital twins, this is a far bigger offering from Microsoft. We're on V2 of digital twins now, aren't we? There was a V1, and now V2 uses Azure plug and play DTDL, device twin domain language, I think it is, to be able to specify the capabilities of all of these particular devices, all the way down to an instrumented individual device level. But then you can put that into a bigger map and show how that fits. I saw a really cool demo on Pamela Cortez's deep dives, where they were mapping digital twins and using them to look at bridges and predict how bridges were going to stand up over time. That was dead cool. A really different way of using digital twins. So yeah, that's my understanding of it. Whether that passed an interview question, I'm not sure, but you know, I think it's close.
You did great. Yeah, I mean, in a nutshell, it's essentially having this potentially huge graph of knowledge about all the things in your system, in your digital environment. And the things may or may not actually be physical things. It can be like buildings, people, like anything really that are just like part of this giant graph. And pieces of the graph might be like synchronized regularly with their physical counterparts. Some other parts might be more like synchronized through automated processes and ERP systems and whatnot. But what really matters is that at the end of the day, you have a complete abstraction of communication protocols, etc. You don't really care about. Like, you care about what is the status of my things and querying the graph so that you can be like, hey, in this particular building at a given point in time, given the specific relationships that are in place at a given point in time, what is the temperature of this particular room of this particular building? And the query might or might not try and access data which is provided by the twin of a temperature sensor. It might maybe get data from like other twins, but at the end of the day, like you're really completely abstracting out the fact that there is some IoT hiccups potentially to get the data from the devices. You just have the data. It's already consolidated in the graph. So back to the sort of our assignment for today, what we need to do essentially now is, I mean, I do have a digital twins instance that we could be hooking your sensors to, but I think we should be switching back to the tutorial and the instructions that I think I shared in the chat earlier, but I will put them again. Like in this particular, and I can put it on screen as well. Like between last week and the past hour, we've set up a LoRaWAN network server. We've provisioned our gateway, our sensors. We now have data flowing into our network server. Like I think I said like half an hour ago, the data, the sensor data right now really literally only flows through the system and there's no one consuming the data. And that's the whole point of the network server. It's here to make sure that the sensors can route data to the internet, but then you need to subscribe to the data to do something useful with it. And now that we have the decoder in place, we are one step closer to being able to do something useful with the data, because it's not a binary, like opaque payload anymore. But we need like a sink, I guess, for the data. Could be many things. We could just route data straight to a NoSQL database, or we could do like things like that, or put it in a time series database. But what we're going to do is connect the ThinkStack network server to Azure Digital Twins, so that whenever the sensor tells us, hey, you know what, my temperature just changed, we're going to have a digital twin, a digital counterpart for the sensor in Azure Digital Twins, which we're going to like synchronize against whenever new data comes into the ThinkStack. We're going to essentially configure like there is this notion of integrations, where essentially whenever data is being sent to the ThinkStack, we can call some webhooks, and in our case, the webhook will be some kind of Lambda function or Azure function, actually, that's going to be in charge of like taking the telemetry and putting that, updating the corresponding twin in the Azure Digital Twins graph. So yeah, Pete, you may want to like share your screen from that point and just go through the instructions. It should be actually pretty straightforward, because we just need you to provision an Azure Digital Twins instance, so that we can start populating the graph with your sensors data.
Sounds good. I liked how you used the word "just" before saying that I need to. I have done this actually. I've done a Twitch stream on this before, and it's I think it might even be on my YouTube channel there. But it's a little while ago since I did that. So yeah, I'm on Benjamin's blog that we've linked to in the chat over there as well. It looks like that. That's what the link is. So I've just opened up in here the quick start for setting up the Azure Digital Twins and ADT Explorer. So this is a service that you must run in Azure, and I think there's a cost involved with this as well, isn't there? I don't think it's a free service.
Yep, but it's actually you pay by the like the bulk of the pricing. And I mean, don't quote me on that, and just look at the doc. But in a nutshell, it's mostly based on how often and how big. How often you query the data, and how big your queries are in terms of like how much data you end up extracting whenever you query the digital twins graph. But you're looking at like fractions of a dollar for per million queries kind of stuff. I mean, it's we can look at the pricing for digital twins.
I've just pasted the pricing of digital twins in the Twitch chat. Yeah, it's based on a million. Yeah, less than $1 for 1 million messages. So not a lot there. Less than £1, sorry.
Yeah, it's also at the top of the screen there. So that makes sense. So I mean, it's like a rabbit hole. This is. So I started it at Benjamin's blog post and to his install instructions, and you go to that, and then it takes you through how to set it up here. And to set that up, it says otherwise follow the instructions, set up an instance and authentication. So you go over to that one, and then now I've got this page here, set up an Azure Digital Twins instance and authentication using the portal. It does mention that we could do this here with the CLI if we wanted to, but I think this is probably going to be better if we do it through the portal and people can actually see the real steps happening. But I think most people, if you're doing any in-depth work with Azure whatsoever, you're probably just going to be using the CLI or ARM templates or Terraform or something like that. But we'll do it with the portal. So we need 2 steps here: create the instance and then set up the user permissions. Prerequisites, permission requirements. I mean, I'm an admin on my tenant, so I don't think I'll need to worry about these roles. To be fair, but it is important if you aren't an admin and perhaps you've not got all of the necessary permissions on your tenant, then you're going to need to make sure that you set up the necessary permissions or have your administrator do that. But the first thing we need to do is create the Azure Digital Twins instance. So I'm going to go to my portal. How long do you think this takes normally to provision, so people have got an idea?
Provisioning is like 30 seconds, something like that. It's actually super fast. And then it's a couple more minutes to go through the to set up the permissions, because even if you're an admin on your subscription, there is still a permission that you will need to be granting on the Azure Digital Twins instance itself to authorize yourself actually to access and to manipulate the Twins graph. Like by default, the Azure Digital Twins graph is completely isolated from the rest of the world, and you need to grant access to people and to applications so that they can start manipulating the graph. So your Twins instance is up and running.
Oh no, I'd already created one from that Twitch stream, so I'm going to create a whole new one here.
Yeah, you can do a new one. Like it's super fast. So I'm not worried about that.
I'm going to go in this LoRaWAN end that I created for the previous stream and go in there. And does it matter where I go? I always choose North Europe here, no matter what I do. But I'm assuming it'll probably be all right.
Yeah, it shouldn't matter.
Yep, and I'm going to call this LoRaWAN. Is it going to let me do dashes? DT, Digital Twins. In fact, can I do that? No. Okay, that's what I'm doing. LoRaWAN DT is good enough. We'll know what that is. A public endpoint, which is fine. I guess we're going to need that. Advanced. If you turn System Manage Identity on, we'll register this Azure Digital Twins in your AD. Once we do, you'll be able to grant it permissions and access protected resources. Let's just make sure I'm not going to miss a step when I'm creating this, because something like that sounds like it might actually need it.
So this one we don't need, because and it can be confusing, but this one is the identity should you want to give digital twins access to other resources, as opposed to what I was going through just before, which is we will need to give yourself or other applications permission to manipulate digital twins. Right. So yeah, we don't necessarily need a managed identity, or that is like we would if we would like digital twins that to be in charge of like directly modifying third-party resources or things like that, but we won't be looking at that.
So would that be like digital twins reaching out to an SQL database or Cosmos DB or storage and manipulating data there? So taking the data and sticking it over there. Is that what you?
Yeah, pretty much. And more specifically, it would be for things like digital twins, a use case would be more around eventing. And whenever there is a change in a particular subset of the digital twin hierarchy, you want to push data into event grid or like some kind of eventing mechanism. So the identity would be what would be used to authenticate against the event grid endpoint, right? As opposed to if you don't have this notion of identity, you may end up hard coding credentials in the system and so on. And it's much more elegant to use the identities there.
Mm-hmm. So that's provisioned, and I've gone to my resource now, and it's telling me that this is quite an important variable to take there, that host name, that parameter rather. What's it say? These are the important. So overview, name, resource group, and host name. So they all make sense for the users we're programming against this instance, and you can share those values. But it'll be that one that we'll need more than anything.
Mm-hmm. Yeah, and the user access permissions you will need to go through as well, so that you give yourself the permission. So you can go to the access control IAM
here.
Tab. Yeah, or just essentially all those entities that will need to manipulate and to interact with digital twin, they need to have the Azure Digital Twin owner or the Azure Digital Twin data reader kind of permission. So in our case, we want to what those steps are telling us is it's recommending that you add yourself as a digital twins data owner for this particular instance, which makes sense, right? So the role you're going to give yourself is data owner.
Yep. And then I need to put me on there. There we go. Selected members, and then save, I guess.
Yeah, the select. So make sure that you put yourself here.
Yep, and then that is me there as a digital twins data owner. So that's fine. So I've done that one. Verify the success. Yep, I've just been into role assignments and verified my success. So that is the end of that part. And then set up local Azure data credentials. So the ADT Explorer application uses some credentials by the looks of it. For more information, blah, blah, blah. This type of blah, 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 blah. Follow the so otherwise you can install the local Azure. If you already signed into Azure through one of these ways, you can skip on to the next section, in fact. So you can do that. Run and configure the ADT Explorer. So I think I've already got that installed somewhere, but I'm going to do it again because it will most likely be configured to be pointing to the other ADT stuff that I've gone. So go to the downloaded and unzipped. Well, I've not downloaded anything yet. So is it this? No, that's just Azure CLI. So where's the download that it was talking about for? Here. Maybe the ADT Explorer there. Oops. Not that. Miss. Yeah, so it's this. And download this zip.
Yeah, because right now you have a digital twins instance. You have the ability to authenticate as you, Pete, against the APIs, and you can probably start using the CLI or the REST APIs to do something and start maybe populating the graph with some twins and so on. But yeah, this might not be super user friendly, so we're going to use a UI to do that. So the UI is something that we need to run locally, although I think there is a Docker container version of it that might be slightly faster to bootstrap, but it should be still should be fairly fast.
Yep, I'm just going to get a good place to download this to. You can't see this, I'm just doing this off the screen. And then I can drag this on and carry on. Hold on. ADT. And then make the screen a little bit tidier. And then I can bring this down here. There we go. So that's my Azure Digital Twins Explorer. And then I can extract that to extract it here. Cool. And blah, 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 blah. Getting started, run it locally. So we've already set up the instance. In order to authenticate, you need to run AZ login on any command prompt. So I probably already am, but we'll do it from here anyway. Bring that on the screen and zoom in a bit. Let's actually see what we're doing. There we go. What was it? AZ login. Oh, okay. I wondered what it was doing. It was just slow. You have now logged in, so that's okay. Where did we get to? Where are we? I've lost where I was now. Where was that instruction that I was reading and it's gone now?
Don't know, because I've completely frozen this end.
Oh, it's what? Have you?
Yeah, I've my whole machine's frozen. So obviously you can clearly still hear me. Not sure if you can still see me.
Yeah. And it's still coming out.
Yeah,
it looks like
cool.
on the stream. It's just. Oh, here we are. So AZ login. So that's fine. After you log in, so possible last step. If you use multiple Azure subscriptions under this account, set the authentication context. I might need to do this though. I might need to set the subscription. So I'm going to do that off screen. So AZ account set. I need to set it to the correct subscription, and to do that I need to find out what subscription I'm in, which is fine, and you can't see that because I've turned that off. Hold on a minute. Keeping stuff away from prying eyes is easier said than done, actually. So I've got the AZ mask extension on there, which means I can't see. So yeah, okay, so it ends in 6.7, so that's fine. So I'm just going to bring this back on the screen now so you know what I'm doing. So paste that in here, and then where's the one that ends in 6.7? There it is. Control and M to mark, and enter, and enter. Oh, jeez. There we go. So set my subscription, clear the screen, bring that back on again. There, so I was obfuscating all of that. I suppose I could have just done it on off of screen share, but you know, what fun would that be? Moving stuff around screens is far more interesting, isn't it? So after you sign in ADT, blah, blah, blah. So run and configure. So npm install is what we need to do first. Go to the download and unzipped Explorer folder, open a console window, the location client source is where we need to go to. So we have a client, and we're going to, in there, we're going to have a source, and we need to do npm install. This is where you find out that I've got like version 1 of Node and npm rather than the version they need. And we're going to package hell. Let's see what it does. I mean, you could argue that we could have done this off stream, but I mean, this is the whole point of what we're doing, is to do this live and show how you go through doing this. Let's have a look. So my command prompt is being given all of 10% of my CPU, while OBS, aka Firefox, is taking the other 90% just to be able to show you what's on the screen. Very frustrating. It refuses to use my GPU as well. The desktop is using my GPU, and the camera is using my GPU, but Firefox is using all of my CPU and none of the GPU to do what it's doing, which is very frustrating.
Pete, you've still got the link generator showing up on screen as well. You might want to close that.
That's true.
I think everyone's got with the pricing of digital twins now.
Fair. There, it's gone. Tell you what, I could have put in that link generator was the link to the tutorials that I was running through. That would have actually made a lot more sense. But it's rather large. There we go. It's a little bit big, but it should be okay. word wrap does its trick. So that's still installing, so hopefully it'll be done shortly. And SSD is only as fast as the CPU lets it be, of course. So for those that don't know, the Azure Digital Twins Explorer is a way to be able to visualize these digital twins. It's a really cool piece of tech, actually. So digital twins are a big JSON document, I think, essentially they are, aren't they? But that's not very nice to look at, certainly not when you've got potentially hundreds or even thousands of items in there. So the Digital Twins Explorer gives you a nice graphical way to be able to drag these things around and see the tree in a more graphically inspired way. I do quite like it, actually. I think I had a couple of issues while I was running through the stream originally, but I think I was using like the very first instance of V2 of Digital Twins while I was doing it, so no doubt I was coming up against the odd bug here and there. And in fact, somebody approached me from the support team and dialed in and helped me to get around that. I forget what his name was now. He's a fantastic chap. And I think we follow each other on Twitter now. Nice guy.
So what's the next step while we're waiting for this to install in, Pete?
Let's have a look. So run it, and then when you do run it, we will get a browser window opening. Interesting, I think they're also, let's search. And then we need to sign into that, and then enter the Digital Twins instance URL that we had in our over here. I don't mind giving that out because obviously you need to know my credentials in order to be able to use that in any way. So I don't see that as being a great problem. We're nearly finished. Not long. So once it's done that, here, yeah, so we sign in and then enter that information. Note you can revisit or edit this information at any time by selecting the same icon. That's fine. And then they're going to add sample data, but we're not going to do that, Monsieur Benjamin. We're going to start looking at adding real data into this. Yeah, here we are. Look, JSON LD, Digital Twins definition language, not domain language. And each model describes a single type of entity in terms of properties, telemetry, relationships, and components. And I think that DTDL is the same thing we use for plug and play, isn't it, Benjamin? For services that like the plug and play in IoT Hub, but also plug and play in IoT Central and stuff like that.
My audio was dead for the past 2 minutes. So what was that?
Oh, okay, nice. That's fine.
Literally dead, both ways. So.
That's bad. Well, I think I could hear you. Interestingly, you just couldn't hear us, which is weird. But either way, yeah, DTDL is the same language we're using for Azure Plug and Play as well, isn't it? And that's used in things like IoT Central to be able to define the capabilities of devices.
Yep. One thing I was about to say before my audio crashed is that if you haven't already, you may want to clone the GitHub repo for the tutorial, because as soon as we will have the Digital Twins Explorer up and running, which looks like it's almost there now, we're going to want to populate twins into the graph. But for those twins to be created in the first place, the Azure Digital Twins instance will need to know about the meta models, if you will, for the various twins. So we will need to specialize sort of our Digital Twins instance for our particular use case. And our use case is going to be something along the lines of home automation slash smart building scenario. And so we need to instruct digital twins about what kind of entities, and those entities will be described using DTDL, what kind of entities we want to manipulate. So things like, I want to have a building. A building has a name, a building has a GPS location, maybe, and then a building may be connected to a room. And what is a room? A room is a something with a temperature, an average temperature, and with a size and blah, blah, blah. And then we have sensors and so on and so forth. But those model descriptions for what will be our twins eventually, those meta models, they need to be in the system. And in the GitHub repo, you have the models that we will be using as a starting point. Now, of course, when I built the tutorial, I didn't know about the particular characteristics, the particular description of your temperature sensors. So at some point, and it will probably be next week actually, but we will need to create the DTDL model for what are the capabilities of the sensors that you're going to add in the system. Because right now, the tutorial is meant to manipulate those LoRaWAN sensors that I think I've mentioned before, and we will need to add the description for yours, and we will need to be like, hey, you know what? A room, originally a room as per Benjamin's original model, it could only contain this kind of sensor, but we're going to add another category of sensor, which is the ones that you will be describing, and yeah, that's essentially the idea.
Right, interesting then. So I've cloned your repo into I'm just up in the ADT. I created a directory repo and cloned it into there. But I've gone back into the Digital Twins Explorer now, and I'm going to run it. I'm assuming that's what you want me to do.
Yes.
Let's do that then and see what that does. Hopefully, it doesn't blue smoke start coming out of my laptop and stuff like that.
Won't be an IoT show without smoke.
That's true. That's true. I need to figure out why some of these shortcuts work and some of them don't sometimes. Right, so what I've got on my screen now is allow access through the firewall, which I need to do, so I'm going to do that. It is doing it. And in the background, starting the development server. And again, this would normally be faster, but OBS Ninja. Oh dear, come on. I think it's even slowing down the screen share in OBS Ninja. I can see whatever's going on with that. Yeah, it's using now 20% of my CPU, so that's stealing away from the screen share. But I don't think it's not too bad. It's fine. It is actually not too bad on the stream itself.
Looks good here.
It's usually faster than that, though. Is the V1 of Azure Digital Twins still going at the moment, Benjamin, or has it been completely deprecated now? Do you know?
That's a good question. My guess is it's not possible for folks to create new instances, but like it might be that there are existing deployments out there, people like still running on the old version. But yeah, I'm not quite sure actually.
I think I read that it's in depreciated. So yeah, it's like just like the Gen 1 of storage. It's there, you can select it, but it's like, you know, there be dragons kind of thing. That's my understanding of it anyway.
And this is still doing something. It's gobbling up 25% of my CPU for saying that all it appears to be doing is flashing that cursor there. It is actually doing something, and it's still loading that tab in the background. Oh, maybe, I don't know, the project is running at that. Webpack, blah, 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 40 seconds for back to. Let me just try refreshing this, just in case it had timed out or something. And I might need to just Control-C and do it again, because it might be caught in some weird loop. This came out, I don't know, it must be 6 months ago maybe, Azure Digital Twins. It's been out for a little while now, hasn't it? So it's Not brand spanking new. Let me Control C. Just make sure that, yeah, it disappeared immediately. So it definitely was doing something. I'm just going to run it again and just see if it was the firewall prompt that confused it there somewhat. It should probably still open another tab for me. Oh, the benefits of doing stuff live where we actually have to wait for stuff. Let's see what this does. It's still doing the same thing, and then it pops up to 20% CPU, so it's definitely doing something. It's just very slow at it. I mean, while that's doing that, Benjamin, I'm assuming you've got this same thing on your machine. Is that something that you could show while this is waiting to start?
Yes, I was thinking just that. Let me just share my screen again.
Yep. There we go.
So yeah, what you're trying to open on your machine, I have it running on mine. So it's running against my particular instance of Azure Digital Twins. And what I was telling before, what I was describing, actually, let me look real quick. I might have an empty, yeah, no, I thought I had another instance that I could switch to that would be an empty vanilla one, but never mind. Yeah, when you start the Azure Digital Twins Explorer, you see nothing because, I mean, the first time you connect it to usually a brand new Digital Twins instance, and there's literally no twins whatsoever in there, and there's literally no models. The models are what I just described before, right? When you start creating and it looks like your server is now running. Yeah, when you start creating a digital twin solution, you need an ontology, right, of what it is you're going to manipulate. And yeah, maybe you just switch to your stuff now, and we can look at how you would do it.
Sounds like a good plan to me.
There's interesting. There's actually a sample model in there. That's new because usually I thought it would start with something completely empty, but that's actually nice because you. So yeah, so two things. One is there is the beginning of an ontology in your particular instance. If you look at the info icon for the sample model, we can probably have a quick look at how, yeah, so it's essentially telling us that in this particular digital twins instance, it will be possible to create and to manipulate twins that are of type sample model, and if and those twins being of type sample model, they will have a property called data, which is a string, and they will have a relationship towards stuff. In this particular case, the relationship doesn't seem to be particularly constrained, and so it can be linked. A sample model thingy can be connected to another sample model thingy. So that's for that's not super useful, but that's what you're able to manipulate already in your digital twins instance. Now, if you run the SQL-like query that we see at the top of the screen, what happens?
Look at this.
Well, actually, interesting. There's also some sample twins in there. So that's the beginning of our twin graph, right? Already in this particular solution, you have some virtual digital counterparts for things that happen to be super simple ones, but you could be already doing multiple things. You could be using the digital twins APIs to programmatically update the data string field of those twins to reflect what is like the current actual state of those things, whatever they are. You could be doing things like writing more complex queries rather than looking at and trying to retrieve all the twins as we see in the query. You could be more like, hey, what are all the twins that have that don't contain any other twin, right? And so you could be like select from digital twins where relationship equals nil, right? This kind of stuff. And so that's a starting point, but what we want to do is really start building our own solution where rather than manipulating sample model instances, we will manipulate instances of buildings, floors, rooms, sensors, and all the relationship that you can think of between what I just enumerated, right? So in order to start creating this ontology, you can either reuse existing models that start being available out there, DTDL models of existing sensors, DTDL models for existing ontologies that are popular in the industry, like for the smart building use case, there is an ontology called real estate core, which is something that you could just reuse as is almost, right? And but if you take the route which is more, I want to author my own models, then you can use VS Code and just start like writing the DTDL models. There is an extension that can actually help you in doing that, and you end up with models such as the ones that can be found in the repo for the tutorial. So the building, the room, etc., is something that's already there. So maybe you want to import those models in the system, right? So if you've cloned the repo for the workshop, there's actually a set of models there that we can import. And maybe, I would suggest that you import those.
So shall I kill off these sample ones first so we don't get confused, or am I happy leaving them there?
Sure, it might not let you do that.
Yeah, because these.
I think you can delete the either the model is deleted, but it's not like it's still there if needed, and then you can also delete the actual twins if you want to.
It's just big house storms just started. You probably even see it. It's that heavy. You can probably see it in the camera footage.
I can hear it. I heard it in the background.
Yeah, it's almost like snow out there. There's not much hail on the ground. Hey.
So I can upload a model.
Yes, and you can actually upload all the models at once. So in wherever you cloned the LoRaWAN ADTD models, so you can take the 3 models at once. And
all of
I
them,
think so. Yeah, what we're going to do is import all those. Start sort of creating what we think should be the model for maybe your house, your building. And so for that, for each entity, you can click the plus icon and start like creating stuff. So you can create a new building.
I'm always a little bit, I don't know how they cope with sticking in apostrophes, so I tend to leave them out in things like this because I've done that before and it's broken stuff.
Yeah, well, I think you will want to get rid of the blank as well, because this needs to be some form of unique ID.
I'm going to do it like that then. In fact, let's do it like that. And imagine that I've got more than one house. That would be nice.
Yes. Yeah. It should, eventually this becomes a huge knowledge graph of all sorts of buildings. Yeah, and now you can create a couple of rooms, maybe.
Let's do.
And so it may sound cumbersome or maybe artificial to be doing this by hand. I think it kind of makes sense to do it by hand when you start creating the solution initially and developing and building the solution. But eventually, in like a real world production environment, it's likely that you would be like seeding the twins, the graph with stuff coming out of maybe a CSV file or things coming out of some kind of export from an existing ERP system where you have like all the information about your buildings, etc. You get that information and then you import it in the twin graph to sort of seed the graph. But here we do it manually, and then if you were to link the rooms to the house, you can first select the house and then you shift click the room, and then you can, so it might be confusing, but you click the house, then you shift click the room and you right click, and you should be able to add a relationship. Yep. Right, or in the toolbar, you just use the this one. Yeah, perfect. And so automatically the tool is only letting us create those relationships that are allowed and that are part of the model. Like the model of the building explicitly says that it can contain rooms. But for example, if you try to link a building to another building, it's not something that's possible because it's not part of the model and the class diagram almost, if you will.
But I can connect a room to a room, but I can't connect. I can connect a room to a room. Interestingly, I wasn't expecting to be able to do that.
Yes, because that's part of the. You can Well, you can actually look at. Just use the info icon again, and there's something interesting exactly to your point. So we're looking at the room. The room has a relationship called contains, which, as per the description, allows to associate the room to stuff, and the relationship is loosely defined. It has no constraint whatsoever on the type of what should be the other end of the relationship, as opposed to the building. If you look at the model of the building, you will see something quite different there. So if you use the info icon to look at the model for the building, this time around, there is also a relationship named contains, except this time it only allows to express relationship from buildings to rooms. And we could even have the cardinality in there. We could be like, hey, there is a maximum of 10 rooms per building and blah, blah, blah. And I think
that you could break that down for floors and things. So make sure you don't have too many, like a duplicate of, say, more than 4 toilets on a floor, that sort of thing.
Yep. And there's actually
could you export this? Sorry.
No, you go ahead.
I was just going to say, can you, you're saying you can export this from other programs, but that's the sort of data for a building you'd want to get from, say, the architect that exports it from, I don't know, AutoCAD or whatever it is they use.
Yes.
There's
like, interestingly, you can import Excel files in through the Digital Twins Explorer if they have the proper formalism. You can do it that way. So you still need to get the Excel file at some point, but there's that. Or there's also for, like, especially for real estate management and smart facilities, there are some standards. I'm just grabbing the link to put it in the chat. There's a GitHub repo. There is a consortium called Real Estate Core, and they have already addressed, like at the meta model level, at the ontology level, they've already figured what it is, like what is the best way to define a building and to define the fact that a building may have HVAC systems, and what is an HVAC system in the first place? It's containing this and this and that, and you can actually maybe quickly go, or if you share my screen again, Pete, I can just.
Yep.
And I think actually,
that should be you sharing now.
It's even got some samples of the digital twins query language as well, of how you could break it down to get the HVAC serial number, for example, and things like this.
Yeah, exactly.
It's quite impressive.
Yeah, there's I don't think there's something like 500 different entities, all the way from like the electrical wires almost that you may be finding in a building, and the space occupancy sensors, and etc. So that's and they to your point about using things like AutoCAD and so on, it's meant to be an industry standard, right? So translating existing CAD models and so on to this format shouldn't be an issue, because hopefully there are some industry tools and well-known tools that already support this standard, so you can have interoperability that way. And where was the query that you were referring to? Is this on the README? Oh yeah, it is.
It was on the README further down. Yeah.
Yeah.
So it's got for someone who understands a bit of SQL, that's pretty easy to read, isn't it?
Yeah. It's pretty straightforward, and so I think we will be keeping that for next week though. But we will be doing something very similar, except that rather than just reusing the real estate core ontology, and just for the sake of the exercise, I guess, we will be using our own models, just like we've started to do, right? With importing the room, importing our own definition of what is a building. But we will be next week, we will be writing similar queries against I guess you could say a very, 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 very small subset of something pretty similar to the real estate core ontology thing. So what's missing and what remains for next week is making sure that in terms of description of the different entities that you will want to have in your digital twins instance, Pete, we will need to add the description for the new sensor that you just acquired, and for which we don't quite have the DTL model just yet. So we will need to write that guy, make it part of the of our model. We will have buildings, rooms, and temperature sensors of this particular brand and this particular type. And then we will start feeding actual data into the twins graph, like the buildings and the rooms. I think it's fair to assume that they're meant to be fairly static, but the twin corresponding to the temperature sensor, this one guy will be actually automatically sort of populated and synchronized from the thing stack to the twins digital twins instance, right? We'll be hooking up and using a webhook to automatically, whenever there is a new temperature uplink being sent by the sensor, it will be routed to digital twin, and therefore it will be queryable from that point, right? And we will be like, hey, what is the temperature of that room again? Does it contain a sensor? If yes, then that's my information, right? So we will be writing this kind of query.
I like it. That sounds good. So that was good. Yeah, I mean, we're about at the top of the hour as well, so that's good timing, that is. So thanks very much for the people that stuck with us. I don't know quite how many people we've got left, but yeah, I appreciate the time you spent with us today. I mean, obviously we've been doing this live, so you've watched it in real time. But I don't think anything took particularly long, other than spinning up that ADT, which is partly because of the fact that I'm streaming from here too. So bear that in mind. But yeah, so next week we'll write a little bit of ADT, DDTL, DTDL to get my sensor into the system and then work out how to go from the thing stack into Azure Digital Twins, which will be pretty cool. I don't know how far we'll get on from that to Blender. That might end up being another one entirely. I don't know quite where you think we might get in those 2 hours, but we'll see, I suppose. But obviously,
I'm trying to think. Yeah, I don't know. Like, on one hand, I'm like, it might be like 2 hours is a lot of time for people to digest all the information. But I mean, you folks tell us in the chat or in the comments on YouTube if you feel like we could be having some stuff already prepared on the side and just like save some time, or if you'd rather have us like do like we do, like going through all the details in actual real time. Yeah, just tell us. We could go and do it either way.
Yep. Or contact us at IoTeaLive, IoTea Live. You can get in touch with us there as well, or any of our particular Twitter handles that you can see below our names there as well. You can get in touch that way too. If you've not had enough IoT, then it's not IoT tonight, which is a virtual, as they all are, meetup now. And we've got Terence Eden and Peter Shaw talking about. Terence Eden will be talking about the Connected House of Horrors, where he's highlighting all of the connected devices that you've got in your home and how dangerous they are. And Peter Shaw is showing you how to build your own USB gadgets. So that'll be cool. Monday coming up is Not IoT, and we've got Myra Renzel from the .net website, one of the architects in charge of that website, talking about how they made that website. So that's all Blazor and WebAssembly. So it'd be quite interesting to hear the story behind that. And then Tuesday lunchtime is Azure Live at 12:30 GMT. So it's 6:30 GMT tonight for Not So IoT. 6:30 Monday night GMT for .NET Nuts. 12:30 GMT on Tuesday for another episode of Azure Live. And then Cliff and I will be back on Tuesday night at 9 PM GMT to chat about your Prusa printer, amongst other things, I believe.
We're going to talk some IoT and some 3D printing, not just the Prusa. I'm going to try and cover kind of the printer ranges that you can get and the typical kind of gotchas that get most people. So we try and cover off most of that if we can.
Yeah, sounds good. So in the meantime, thank you very much to Cliff for joining us, and to Benjamin. Very much appreciated for all the time and effort that you put into getting this stream up and running. It's very much appreciated. And we thanks to everybody for tuning in, and we will see you all very soon. So thank you very much indeed.
Bye.
Bye.